Let's look at ratio and proportion. And just to talk about what a proportion is, it's where you're comparing two quantities with like a fraction. So you might have 2 cups to 3 cups. Maybe you have 3 cups total and 2 cups of it are water. So it's giving you some kind of comparison. Now, a lot of times it's written this way, but you also can write it in this manner. You see sometimes it's written in this manner. So different ways you can write a ratio. Well, let's look at our first problem. It says write the following relationship as ratios using a colon. So 10 hours out of 24 hours. Now, let me put in fraction form first. I think fraction form is easier to think of on this. Okay, so we got 10 hours over 24 hours. Well, since these both have hours here, we can cross those out. And that gives us 10 over 24. And these are both divisible by 2, so that gives us 5 over 12. Now, write it as ratios using a colon. We'll now switch over to our colon, and that would be our answer. Again, we leave it in fraction form because it's easier to simplify a fraction, think of it in those terms. Now this says write the following relationship as ratios using a colon. We got 2 cavities, 12 teeth. The 2 part goes down below, so 2 cavities to 12 teeth. Well, this reduces 1/6, and if I wanted to leave those there, I could. Different books do different things. Some like to leave it in this form because then you can write it as the ratio is 1 cavity per 6 teeth. So what that means is one out of every 6 teeth you'll have 1 cavity. And then if you just want to deal just with the numbers, you just drop the cavity and teeth and be 1 to 6. Let's take a look at some more ratios. 30 and 7 1/2. Well, again, we think of this as division. So instead of putting in fraction form, I'm going to put a division there. That's the same as fraction. 7 1/2. And we can change this to an improper fraction. We take 7 times 2 is 14 and add 1, and that gives us 15. So I got 15 over 2. And if I'm going to divide fractions, it's handy if they're both fractions. So I can put the 30 over 1 divided by 15 over 2. So I got 30 over 1, and we immediately rewrite multiplication. So that'd be 2 over 15. Oops, try it again. Now again, when you're multiplying fractions, if you can divide a number on top and a number on the bottom by the same number, do so. Here's 30 and here's 15. They're both divisible by 15. 15 divided by 15 is 1. 30 divided by 15 is 2. So we'll have 2 over 1 times 2 over 1. Multiply the top parts together. 2 times 2 is 4. Bottom parts, 1 times 1 is 1. And to put this back into ratio form, it'd be 4 to 1. So that's how you simplify it. The easiest way is to write it in division like that. Now sometimes it's easy just to write in fraction form like this, and you can simplify it. Let's take a look at this one. Got 80 over 60 colon 16. Again, we can think of that colon as a divide. So, and I'll put this over 1. If we're going to divide fractions, they both should be fractions. We immediately rewrite multiplication, so I'll put that as 1 over 16. And now I'll start reducing. Here I got 80 and 60. Those are both divisible by 10. A little bit more than that, but we'll start with 10. 80 divided by 10 is 8. 60 divided by 10 is 6. So we got 8 over 6 times 1 over 16. Here I got 8 and 16. They're both divisible by 8. 8 divided by 8 is 1. 16 divided by 8 is 2. Now there's nothing else left to simplify, so we multiply. We got 1 times 1 is 1. 6 times 2 is 12. So to put it into the colon form, if that's what they're wanting. Oh, right, each answer is a ratio. I guess I should actually read the... doesn't say colon, so this would be fine here. If they wanted a colon form, this is how we'd write it, 1 to 12. Take a look at another one of those. Now again, this means 20 divided by 6 over 5. And we'll rewrite the 20 as 20 over 1. And rewrite as multiplication by flipping our second fraction. Now, this number and this number both divisible by 2. That gives us 3. And this gives us 10. So 10 times 5 is 50. And 1 times 3 is 3. So this is what it would look like if we put in a colon form, but that'd be our answer. Take a look at this one. We got 0.6 colon 20 over 9. Well, 0.6, the 6 ends in the tens place, so I could rewrite that as 6 over 10, and the colon becomes a divide, 20 over 9. We're going to rewrite this as multiplication, so I flip that. Becomes 9 over 20. And looks like 6 and 10 I can reduce. They're both divisible by 2. So that gives me 3. And 10 divided by 2 gives me 5. So we got 3 over 5 times 9 over 20. Doesn't look like anything else will simplify. Multiply top parts together. 3 times 9 is 27. Bottom parts, 5 times 20 is 100. So that form, or if you like the colon form, it would look like that. Okay, so here we got 5 and 1/6 colon 3. Okay, now I'm going to change this to a mixed number, or I mean a improper fraction. 5 times 6 is 30, plus 1 is 31. And I'll make that as division, and 3 I'll write as 3 over 1. Okay, so we're going to immediately write as multiplication, so it become 1 over 3. And nothing will simplify there. So 31 times 1 is 31. 6 times 3 is 18. Or I could write it in that form there. And one more. It says simplify the following ratio, write each answer as a ratio. We've got 3 and 1/3. And there isn't any colon here, so there's no divide, but let's put this in improper fraction form. 3 times 3 is 9, plus 1 is 10. So that comes 10 over 3, which that'd be our ratio. So 10 to 3. Now these next problems, let me save this first, and then we'll look at them. Ratio and proportion, page 01, PDF. A proportion is when you've got a ratio equal to a ratio. Actually, let me write it down there. A proportion is a ratio equal to a ratio. And it's not just a single fraction equal to a single fraction, but they're in proportion. So that if this is 1/2, this would be 2/4 type of deal. So they're basically the same value. Let's look at the number 9. We're given 9:2 equals 27:6. And it says, are these ratios proportions? I'm not sure what I've done just right there. Okay, there it is. I'm out of it. Well, if I put these in fraction form, they would look like this. And what they're wondering is if this is true. We're not saying these are equal. We're wondering if that's true. Well, how you determine it is you cross multiply. And you can always do that with proportions. What I mean by that is we're going to take 9 times 6, and we're still wondering this, and 2 times 27. Well, 9 times 6 is 54. 2 times 27 is 54. So they are indeed equal. That means, yes, they are a proportion. So if you cross multiply and you get these equal, then they're set up as a proportion. Let's look at this one. We got 3 to 4 equals 7 to 2. Now, if I set them up in fraction form, again, what we're wondering is if this is true. Well, if we cross multiply, 3 times 2, we're wondering if that's equal to 4 times 7. Well, that gives us 6, and that gives us 28. They're not equal, so our answer would be no. That's not a proportion. I'm going to open my window. I'm getting kind of warm in my room here. I opened it or shut it earlier because the dog was yapping. I think she's going senile as she's getting older. Okay, let's look at this one. What they're wanting us to find here is, says solve for x. We're trying to find the missing x value that causes this to be a proportion. Well, let's set it up in fraction form. This would be 5 over 10 equals x over 4. Now, no matter where you are in math, if you can simplify your fraction, you should go ahead and do it. Here we got 5 and 10. Those are both divisible by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So we have 1/2 equals x over 4. Now, a proportion is where you got a single fraction equal to a single fraction, which is what we have here. And if you have that, you can cross multiply. So we're going to take 2 times x, which gives us 2x, and 1 times 4, which is going to give us 4. Now we're solving for x, so we can divide both sides by 2 here to get the x by itself. 2 is going to cancel, and we get x is equal to 2. So that's the value, if we were to plug it in here, would cause this to be a proportion. Let's look at another one. Got x colon 1 equals 2 to 8. Okay, let's set this up. X over 1 equals 2 over 8. Now I'm going to reduce that 2 over 8. Top and bottom both divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So this becomes x over 1 equals 1 over 4. Now I could cross multiply, but x over 1 is just x. So x is going to equal to 1/4. That's the value we'd have to put in here for this to be a proportion. One more. We've got 3 to 8 and 5 to x. Again, I'm going to put this in fraction form. So I got 3 over 8 equals 5 over x. What comes first goes up top. What comes second goes on the bottom. Now I'm going to cross multiply, because this is a single fraction equal to a single fraction. Like that. Well, I got 3 times x, which is 3x, and I got 8 times 5, which gives us 40. Then I'll divide both sides by a number in front of our x to get rid of that. And when I do that, This 3 is going to cancel. And we got x is equal to 40 over 3. That's the value I'd have to plug in for x to cause that to be a proportion. And let me save that. There we go. Okay. Next is some conversions, and they imply they want you to do these conversions with proportions. There's a problem with that. It's kind of hard to do every conversion with proportion. I'm going to do 1 or 2 of them so you can see it, and then I'm going to go back to I'll show you dimensional analysis, which I like a lot better. Okay, so this one I got 31 feet. And they're wondering how many yards is that? Well, if I come back up here to my table, I'm looking for something that ties feet to yards. This is like X. We don't know what that is. Feet to yards. 3 feet is equal to 1 yard. So there's something that ties it. So this one, this would be like 31 feet over X yards. And to set up as a proportion, I do an equals, and I look over here, and we said 3 feet is 1 yard. Feet is on top in this fraction, so the 3 feet has to be on top in this fraction. And this would be 1 yard. Okay, so feet, yards, has to be matching, just like you see right there. Well, if you have those, and you can drop all the feet and yards, and we got 31 over X equals 3 over 1. And this is a proportion, so I can cross multiply. Well, 3 times x is 3x, and 1 times 31 is 31. Then I'm solving for 3, so I'm going to divide both sides by 3. And we get x is equal to 31 over 3 yards. Now they might want that in mixed number form. That'd be 10 and 1/3 yards. Well, let me show another one using proportions, and then I'm going to switch over like I say. So let's come down to this one, number 15. Got 16 quarts equals blank gallons. And I think GAL is the abbreviation, but if it isn't, we'll pretend it is. So I got 16 quarts over X gallons. That's what we're trying to find. Okay, so the fraction on this side, we're looking for something that ties quarts to gallons. So let's come over here. Quarts to gallons. 4 quarts is equal to 1 gallon. So I got 4 quarts is equal to 1 gallon. Okay. Quarts, gallons. If you got those to match, then you can go ahead and drop them. So we got 16 over x is equal to 4 over 1. This is a proportion, so I'll cross multiply. Like that right there. Well, 4 times x is 4x. 1 times 16 is 16. Then divide both sides by 4, because we're trying to get x by itself, so we always divide by the number in front of it on these problems. And we'll do that. These 4 is going to cancel. And 16 divided by 4 is 4. So we'd have 4 for 4 gallons. Okay, let's revisit these using dimensional analysis. They seem like, well, they're pretty easy, you know, quarts, gallons, but what if you don't find a tie between quarts and gallons over in your table? And you have to use a step in between. Then these don't work well at all. So dimensional analysis may seem a little bit tricky at first. Once you get used to it, you'll love it. So I got 31 feet is equal to blank yards. So we're trying to convert from feet to yards. What you do, your first step, is you take what you're converting from and you put it over 1. And then you do it times, and you're going to create another fraction. And you take a look at what unit measure is up on top here, which is feet, and you're going to put feet down here. And we're converting to yards, so I would like yards to be up here. Well, if I come over to my table, we got 3 feet is equal to 1 yard. So this would be 3 feet, 1 yard. Now we're going to multiply. When we multiply, see how feet's here and feet's here? One's on top, one's on the bottom. So they're going to cancel. Well, 31 times 1 is 31. 1 times 3 is 3. Then we got yards. And then this would become 10 1/3 yards. Now it seems like, well, that's not a whole lot different than what we just did, or maybe you might even think it's a little bit harder. But I guarantee, you go to a nursing program, this will help you better. I was tutoring a student the other day on critical care calculations, and I was trying to get her to use dimensional analysis because it guided you exactly what to do. But she wanted to memorize the steps. You know, that she divided by this and this, and the problem with that is if the problem slightly changes, then your steps don't work. But with dimensional analysis, it oftentimes handles that. Okay, let's look at 15. Enough lectures. 16 quarts is equal to blank gallons. Again, with dimensional analysis, I take what I'm starting with, 16 quarts, put over 1. Times, and if quarts is up here, then we want quarts down here. Now, if we find a tie directly from quarts to gallons, over here, 4 quarts is 1 gallon, then I can go ahead and set that up. 4 quarts is 1 gallon. We're not going to always be able to do that direct tie like that. Quarts will cancel here. 16 times 1 is 16. 1 times 4 is 4 gallons. And 16 divided by 4 gives us 4 gallons. And that'd be our answer. Let's take a look at 16. I've worked quite a few of these, or I put quite a few of these in here just because converting is very important in the medical field. Okay, we got 6 pints. And let's try that again. I didn't even write the problem down. Okay, 6 pints is equal to blank cups. Okay, so dimensional analysis. I take what I'm starting with, put it over 1. Now, without fail, this is pints here, so this has to be pints here. Go back up to my table. I'm looking for something that ties pints to cups. See, this is where the problem was. When I was looking through here, I was looking for cups. Because here's 1 cup, that's 8 ounces. Nowhere else do I see a cup. So cups tied to ounces. The question would be, can I tie pints to ounces? Well, pints to milliliters. Doesn't look like it. Now I could tie pints to quarts, and quarts I can tie to ounces. So let's do that. So I'm going to tie this to quarts. Okay, what's the relationship to it? 2 pints is 1 quart. So 2 pints is 1 quart. And we have to add a third fraction. This is quarts here, so this will automatically be quarts here. And 1 quart is 32 ounces. So 1 quart is 32 ounces. So that's quarts, that's quarts. This is ounces, so this is ounces. And up here we said, where's my cup? There it is. 1 cup is 8 ounces. So I can tie 1 cup is 8 ounces. So again, you have to look at how it flows. Here's pints to pints, quarts to quarts, ounces to ounces, then to cup. So this would not work very well at all with a proportion. Now here we got pints, so that's going to cancel with that pints. Here we got quarts, that's going to cancel with those quarts. Here we got ounces, and that's going to cancel with those ounces. Okay, now multiply cross. 6 times 1 is 6. Times that, don't know. 12, 1, 18, 192. And 192 times 1 is 192. And down below here, 1 times 2 is 2. Times 1 is 2. Times 8 is 16. So we got that many cups. Okay, now this reduces. 96 over 8. They're both divisible by 2, at least. And actually, 96 is divisible by 8. I'm not seeing that. That gives us 12 cups. Sometimes it's kind of complicated how we get to our final measure. The only thing that made me think that is I looked at it backwards. I was looking for cups. And I saw cups was tied to ounces. And then I saw here ounces was tied to quarts. And then I saw quarts was tied to pints. And that's how I came up with that flow. Now, I don't have to worry about anything about how it's set up. All I have to know is pints is here, quarts is here, quarts is here, ounces is here, ounces is here. Much easier than trying to memorize formulas. Let me save that, and then we'll go on. And hate that it does that. So let's see what we're on. Guess that's the one we just did. Let's take a look at this one. We got 12 tablespoons. I'm not very good with these abbreviations. Is equal to blank teaspoons. I think that's TSP. Now again, some people sit there and they memorize the formula. Okay, if you convert them from tablespoons, you do this to teaspoons. Well, why memorize it? Dimensional analysis handles that for you. What is that? TBL? I think that's tablespoons. Again, we start with that, put over 1. If that's tablespoons here, this has to be tablespoons here. And we'd like to find some kind of tie between tablespoons and teaspoons. Tablespoons and teaspoons. 1 tablespoon is 3 teaspoons. So 1 tablespoon is 3 teaspoons. Again, tablespoons will cancel here. And 12 times 3 is 36. 1 times 1 is 1. So that gives us 36 teaspoons. Again, I didn't have to sit there and try to think whether to divide by 3 or multiply by 3. Dimensional analysis drives that. Now you do have to memorize these, but let's see. Let's look at this one. Got 6.5 pounds equals blank ounces. It's probably best to put this into improper fraction form. 6 times 2 is 12, plus 1 is 13. So we got 13 over 2 pounds. I think that's LBS. Now, I don't know much about this yet, but if pounds is here, pounds has to be here, no matter what. Let's go see if we can find a tie between pounds and ounces. Okay, pounds to ounces. 1 pound is 16 ounces. Okay, so 1 pound is 16 ounces. Well, the pounds cancel here. And we got the 1 over 1 drops away, so we got 13 over 2 times 16 ounces. 2 and 16, they're both divisible by 2. 2 divided by 2 is 1. 16 divided by 2 is 8. 13 times 8 gives me 104 ounces. So that'd be your answer. Now, if you're wondering, well, how did you do that down here canceling? Remember, you can always put something over 1 to create a fraction. So again, if a number on top and a number on the bottom are both divisible by the same number, do so. Okay, so number 19. We got 6 medicine cups. I'm going to abbreviate those. 6 medicine cups is equal to blank milliliters. ml for milliliters. Okay, I don't know much about this, but I know medicine cup goes up there over 1 times. If medicine cups is up there, medicine cups has to be down here. Now they tell us that medicine cup, 1 medicine cup is equal to 1 fluid ounce, which means I can tie 1 medical cup to 1 fluid ounce. Well, with dimensional analysis, if this is ounces here, this has to be ounces here. And I hope I can find some kind of tie between ounces and milliliters. So let's go look. Ounces and milliliters. Here it is. 1 fluid ounce is 30 milliliters. So 1 fluid ounce, so 1 ounce is 30 milliliters. Okay, so medicine cup here cancels the medicine cup here. Ounce here cancels the ounce there. And we got 6 times 1 times 30 gives us 180. 1 times 1 times 1 is 1 milliliters, or 180 milliliters. And that'd be our answer. And number 20. Okay, so we got 25.5 milliliters equals blank teaspoons. Again, this would be 25.5 milliliters over 1. Don't know anything about this yet, but if this is milliliters, this has to be milliliters. And I want to find some kind of tie between milliliters and teaspoons. Maybe. Milliliters and teaspoons. Teaspoons. Oops, here's 1 teaspoon equals 5 milliliters. So 5 milliliters, 1 teaspoon. Again, milliliters is up here, milliliters is down there. Those can cancel. And 25.5 times 1 is 25.5. 1 times 5 is 5 teaspoons. And that gives us 5.1 teaspoons, I believe. Now, depending upon what area you're going into, the instructions in the homework should tell you this, but this gives you a guide. If your answer is in these, then use fractions if there's a remainder. The reason why I point this one out, this is a teaspoon, and we do got a remainder here. This is the same as saying 5 plus 0.1 teaspoons. And it says use fractions if there's a remainder. Well, this ends in the tenths place, so that's like 1 over 10 teaspoons. So 5 and 1/10 teaspoon. The plus there automatically becomes a mixed number. So again, it's whatever form they're kind of looking for in if you're going into the nursing program. Let's save that. And there it flips me out again. Okay, so ready for number 21. Mm. 800 milliliters equals blank pints. So 800 milliliters equals blank pints. Again, I'm going to convert from 800 milliliters. So I put that over 1. Milliliters up here, so we need milliliters down here. And I hope to find some kind of tie between milliliter and pints. Milliliter and pints. Pints, 1 pint is 500 milliliters. Here it is. So we got 500 milliliters is 1 pint. Well, these milliliters cancel here. And I got 800 over 500 pints, which both of those divisible by 100, so it becomes 8/5 pints. And up here it tells us pints is use fraction, so it'd be 1 and 3/5 pints. If the instructions in the homework actually say to write in decimal, though, put in decimal. Number 22. 5 1/2 cups equals blank ounces. Okay, so this would be and you can put it in decimal form if you're more comfortable with that. But this would be in proper fraction form. 5 times 2 is 10, plus 1 is 11, so that's 11 1/2 cups. Cups is up there, cups has to be down here. Hopefully we'll find some kind of tie between cups and ounces. So let's go look. Cups, ounces. 1 cup is 8 ounces. So 1 cup is 8 ounces. And again, cups here and cups here cancel. Those ones don't do anything, so I'm left with 11 halves times 8 ounces. And I could put this over 1 if I wanted to. And 2 and 8 are both divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So 11 times 4 is 44 ounces. That'd be your answer. Now this next problem, I believe, shows proportions really do have a place. I don't think they're in the conversions that we're just looking at. But this says, if a dose of 200 milligrams is contained in 8 cubic centimeters, how many cubic centimeters are in 600 or 60 milligrams? Well, this isn't a conversion. This is showing you a comparison. So we got 200 milligrams and 8 cc's. So we got 200 milligrams in 8 cc's. And we're going to set this up as a proportion. It says how many cc's are in 60 milligrams. So 60 milligrams, and this would be X cc's. Now milligrams is on top here, so milligrams has to be on top here. The cc's is down here, so cc's has to be there. Again, how many cubic centimeters are in 60? Well, at this point we can drop, since these match, milligram cc's, we can drop those. We got 200 over 8 equals 60 over X. I can simplify this fraction. Top and bottom are both divisible by at least 4, maybe more than that. Actually, both divisible by 8, I think. But let me start with 4, because I can see the 4. Maybe. 200 divided by 4 gives me 50. 8 divided by 4 is 2. And they were divisible by 8, because these are both now divisible by 2. 2 divided by 2 is 1. 50 divided by 2 is 25. So it gives us 25 over 1 equals 60 over X. Since it's a proportion, we can cross multiply like that. So 25 times X is 25X. 1 times 60 is 60. Then we're solving for X. We divide both sides by 25. And those 25s are gone. And these are both divisible by at least 5. 60 divided by 5 is 12. 25 divided by 5 is 5. So this is how many cc's we'd need. And of course, we'd round it to whatever, whether it's decimals or fractions, so forth. Okay. Well, here's some more those problems without all the words. So we got 14.5 milligrams to 6 milliliters equals 29 milligrams to X milliliters. Well, this is just in a weird form, but if I set up as 14.5 milligrams over 6 milliliters equals 29 milligrams over X milliliters. Milligrams, milliliters, milligrams, milliliters. Since they match, I can drop them. So I got 14.5 over 6 equals 29 over X. Proportions, so I'll cross multiply. So I got 14.5 times X. That gives us 14.5X. 6 times 29. Where's my calculator? I don't want to think this hard. Okay. 29 times 6. I get 174. Now, solving for x, we'll divide both sides by 14.5. And those would cancel. And 174 divided by 14.5, I get 12. So 12 milliliters would be our answer. Let me save that. Time for my tablet to blow up. There it goes. And let's look at number 25. This is another one. We got grains. 1/2. It's not GRS. I think it's just, what is it? I think it's GR. Oh well, we'll pretend that's right. 20 milligrams. And then we got grains over here, X, and 80 milligrams. This class is not about memorizing the abbreviation. It's about how to set things up and do the math. So again, since these are grains, these are milligrams, I can drop those, and I just have 1/2 over 20 equals X over 80. This is a proportion, so I'll cross multiply. So I got 20 times X, which gives us 20X, and I got 1/2 times 80. Well, 1/2 times 80 gives us 40, and then we'll divide both sides by 20. Those 20s cancel, and we get X is equal to 2. One more of those. I got 2,000 units to 1 milliliter, and then we've got 2,800 units to X milliliters. Again, it's units, milliliters, so I can go ahead and drop those and just set them up in proportion form. So this will be 2,000 over 1 equals 2,800 over X. I'm going to cross multiply. 2,000 times X is 2,000X. 1 times 2,800 is 2,800. Now we're solving for X. We're going to divide both sides by 2,000. And those 2,000s cancel. And we got X is equal to, and both of these we can drop 2 zeros off the end, and we get 28 over 20, which gives us 14 over 10, which gives us 7 over 5. And again, you know, the instructions on those, they kind of guide you what to do. It says if you have milliliters, use decimals. That's not quite true, but so this one we'd want to convert it to a decimal. This is let's see, divide that by 5, and we get 1, so that's 5, that's 20, that'd be 4, so this would be 1.4 milliliters. But don't count on that for the homework. Read the instructions for the homework, and if I've forgotten any of them, then holler at me, and I'll put that in there. Because Angel isn't as flexible as I'd like it to be, so I didn't have the flexibility to do exactly what I wanted, unfortunately. It didn't allow you to input a fraction. It allowed you to input a decimal just fine. So a lot of places I just put decimals just because that's all I could do. Okay. Now this 27. We got 900 calories of fat is equal to blank grams. Now what they're doing over here is they're giving you a setup so you can do proportions. So we're talking about fat, So we got 900 calories of fat and X grams. That's what this is saying. And we want calories up here, so I come over to the fat. Fat says 9 calories per 1 gram. So I want 9 calories up here, and I want 1 gram here. Again, calories is on top here, grams, calories, grams. Has to match that. If it does, you can just drop them. And so we got 900 over X is equal to 9 over 1. Well, now we'll cross multiply. Multiply those together, multiply those together. So I got X times 9, 9X. And 900 times 1, 900. Divide both sides by 9 to get the X by itself. And 900 divided by 9 is 100. So we'd have 100 grams. Let's do one more of those. So we got 84 calories of protein and grams. So X grams. So that's the setup there. 84 calories over X grams. Now if calories is up here, then I need calories here and I need grams here. It has to match. Okay. So if I come over here, I'm dealing with protein. Protein is 4 calories per 1 gram. So 4 calories per 1 gram. Well, now we can drop those calories in grams, and we got 84 over X equals 4 over 1. And we'll cross multiply. So we got X times 4 or 4X equals 84 times 1 or 84. Divide both sides by 4 to get the X by itself. And we get X is equal to 21. So it'd be 21 grams. And that'd be our answer. Let me save that. And then we'll be done.